All right, thank you all for coming this morning. As I was kind of hinting just a few moments ago, I wasn't sure who was going to show up and what we'd be talking about. So this is a bad session if I talk a lot. So please feel free to stop me at any point, question anything. I feel like I'm going to want to spend just a brief moment talking about what this ionic Viper thing means, but move on very quickly. As I was, you might have caught catching, and I was talking with two of our early attendees here. Inorganic chemists at small PUI institutions are usually a lonely bunch. There's one, maybe two if you're lucky, but generally one. And inorganic chemistry is a very, very diverse field. My training is in organometallic chemistry, coordination chemistry. I'm comfortable in that zone. Solids perplex me. Bioinorganic chemistry scares me. And yet I feel like these are topics I need to bring up in my class to expose my students to. So, you know, I'm trying to teach something in bioinorganic chemistry and I have a question and I don't know about something, you know. I look out in the hall and there's no one for me to talk to. I'm not alone, so a bunch of people many years ago, smarter than I, got together and said, you know, we need to have some kind of community for inorganic chemists to talk and share things. And that was the start of Ionic, the interactive online network of inorganic chemists. Started off with 6 people, quickly became 4, and then the leadership council has grown to somewhere in the 10 to 12 range. It's on the internet at some point, so I'll get yelled at for having the number wrong. I am part of the leadership council of that. We do a number of different things. We host undergraduate research at the frontiers of inorganic chemistry at ACS national meetings every spring. We usually have 2 to 3 oral sessions and a poster session there, and they tend to be early in the week. So if you have undergraduate students, we welcome students as oral presenters and their posters. Please feel free to contribute. We'll be in Indianapolis in March next year. I don't know why, but that's when we'll be there. And we have it for the next one after that, something we've been doing for a number of years. We have a website. That's where this Viper part comes in, the Virtual Inorganic Pedagogical Electronic Resource. It's a place for people to share things from full-on laboratory exercises to a single question that you could use on a test or a problem set, and pretty much everything in between. It's free to anyone to use. There are some parts of it that are faculty access only, so you have to become a registered faculty user to see like answers to problem sets and some particular file. It's not a painful process. You sign up and we review and see, okay, it looks like you're who you say you are and you're approved. The site had started with forums as a site to kind of chat, have discussion. That has morphed. We now have a Discord server with about 150, 200 users on there that's had some really, really awesome discussions. We do some educational research. I'll talk about that a little bit here in a few moments. And gosh, am I missing anything? That sounds like a pretty good quick tour of it. I'll happily talk more about it. You know, if you have any questions or anything along those lines, that's not really what I wanted to go into today, but I will happily do so. So some feedback that I got from people that sort of pre-registered for this SLiTHEr, and this is something that we're doing. It started with the pandemic. We decided to have these online roundtable discussions on topics, and this is serving as one of those. So some people pre-registered. They said they wanted to hear a little bit about absolutely nothing. There we go. What to teach in inorganic chemistry, what to teach in inorganic chemistry labs. And then a topic I threw in there because I didn't know who I'd be talking to, and it was something I wanted to talk about, and that was SD hybridization. We might not get to the last one, and I'm totally okay with that, or maybe we will. So, what to teach in inorganic chemistry? It's hard for me to believe that this paper is 7 years old. at this point. It's almost getting near time to kind of redo it. This paper came out in Inorganic Chemistry, and there's sort of 2 tag-on papers in JChem Ed on what the rough framework for an inorganic chemistry curriculum should look like. And a lot of this comes from the fact if you get together, so start talking to people and they're inorganic chemists, I can almost guarantee you early in the conversation, something along these lines is going to be spoken. It's going to be, so what book do you use? And that's going to be followed by blank. I'm not going to sell anybody's book, but I don't like XYZ aspect of it. I don't think there's an inorganic chemist out there, except maybe one who's using LibreText, free plug for them, who loves everything in their book. There's something that they just don't teach or they don't think is covered the way they want it in their class. Well, a bunch of these folks and many of the authors here are members of the Leadership Council of Ionic, conducted a survey. And what they found out was, the reason no one's happy with their inorganic book is because inorganic classes are really, really different. Orgo kind of follows a pretty set pathway wherever you are. Inorganic chemistry is all over the place. They pulled foundation level and in-depth classes, so kind of sophomore-ish level and more senior level courses. And just looking at the topics that are covered, it seems like in foundation level, there are a couple topics that the vast majority of people, around 300 or so, are covering atoms and electronic structure, bonding, transition metal complexes. But then we hit the variability all over the place. Right? And in the more in-depth level, the senior level, transition metal compounds really high up there. But again, there's a great diversity in the different topics covered.
Just focused on the undergraduate levels that we're talking about?
Yes,
okay.
Exclusively on the undergraduate level, although I haven't looked at the data super recently. There's a decent chance that at least a couple of the responses of the advanced course would be one of those ones that sort of joint senior graduate level, depending on the institution it's being taught at. So what they were able to do, and this is in particular at the foundation level, is kind of come up with 4 different clusters of type of foundational courses, where just kind of comparing the different topics and seeing roughly what the distribution of those topics being taught were. They said, okay, there's a descriptive chemistry kind of foundation course that seems to focus more on some of these topics, fundamentals and selective, more of a foundational fundamentals, and then one that's much more comprehensive, tries to touch on everything a little bit. The big take-home message, there's maybe at best 4 inorganic classes out there running, 4 different types, but even those have variability among them. So all inorganic courses are really, really different. A lot of it comes probably from the instructor's background, what their knowledge base and comfort level is, what their classes were when they were going through their undergrad and graduate programs. There are some, sort of these core topics that seem to pop up in every class, no matter what. Not surprising, inorganic chemists like bonding and molecular orbitals. So they show up in just about every one of the classes. But down here, main group in descriptive chemistry, looks like this group doesn't really like talking about main group chemistry very much. Only a small percentage of those folks report touching it at all, whereas almost 90% we're talking descriptive chemistry. So a lot of variability. Okay, so the in-depth course. That one didn't quite break down into 4 different groups. We had 3 different groups that seemed to kind of cluster together. But again, tremendous variability. Acid bases, 100% of the people in this in-depth survey course cover it, and only 14.7% in the special selected topics course to cover. So both at the foundational level, sophomore-ish level, and the more senior level, there's a lot of differences in the courses, which, you know, makes writing a textbook to these different types of courses really, really difficult, which is why everyone says, I use this, but. So, what I thought would be nice is to share some possible examples of the courses that are out there and give you a little insight into the way Viper works. So this is the Viper website. It's a little small, but it's www.ionicviper.org. And if you go over here to content, we have syllabi. People have uploaded their syllabi from their different courses. So if you were just teaching a course for the first time, you could go through and look at some of the different syllabi that have been posted on the website. There's about 60 or something like this. This is a very low bar kind of, if you wanted to post something and get counted as an electronic publication, it does undergo peer review. And I got to admit that the syllabus peer review is not exactly excruciating. Like, yeah, that looks like a syllabus, okay, and it's inorganic chemistry. We'll put it on the site. So you can go through and see what other people are teaching. You know, what textbook they're using, how many tests they give. Do they give tests? What other sorts of assessment methods are being used in other people's classes? So, you know, if you're going to be teaching a course for the first time, it's a nice starting point. And if you kind of do use things from the site, you're like, boy, I really wish I would contribute back. It's a great low bar first contribution back because people use them. Let's make sure this is not the same. Okay. Is there anything else on the site that might be useful? Well, again, kind of from the perspective of if you're teaching this for the first time, again, under content, you have these things called collections, which are just a whole bunch of teaching resources clustered around something of the same topic. And sorry, these are kind of tiny, but I'll make this available later. Go back here, come on. No. So I picked out a couple of them that are up here, which are really hard to see, I'm sorry. But this is Foundations of Inorganic Chemistry for New Faculty. And what we've done is kind of cluster together a whole bunch of different activities that you might choose to use in your class the first time. I wouldn't expect someone to jump right in and use all of them, but you know, at least it gives sort of a vetted response. Someone's looked through these, they've been used in classes, they work, come on, jump ahead here. Okay. So these are some of the ones that are in this particular collection. We've got some in-class activities. You know, if you're deciding the first time, all right, I'm going to talk about d orbital splitting. So we've got an in-class activity. You might give that one a try. You know, I would again expect you to use every one of these your first time through as you're learning the development. But these different learning objects, they have kind of implementation notes, how you might use them in class. But it's going to vary person to person. You know, nothing posted on there is something that you have to use exactly as it's posted. We very well espouse the adopt and adapt. Make it your own to use it. Use the idea of the framework, but make it your own. We've got some syllabi here. So these are folks that have posted syllabi that are kind of these intro-level inorganic courses. We've got a literature discussion, so pulling in the chemical literature into a class, even at the sophomore level. Some problem sets listed down a little further on. So all kinds of different things that you might find useful when you're making your class for your first time. All right, a little bit more. Again, under content. got teaching resources, and this is one of our web series. We call them Nano Chats. And this particular series of Nano Chats was something this past spring done by 2 members of the faculty at the Naval Academy. They were teaching a sophomore level or foundation level course for the first time. And every Friday they would get together for a 10-minute discussion about what they taught, what worked, what didn't work. It was the 2 of them and sort of a guest host. They're all posted on our YouTube site. So you could go through with them week by week what their experience was as they were teaching it for the first time. Maybe you develop your course just like theirs. Maybe you do something a little bit different. But it's a great way to, kind of share with someone else a shared experience without having been there. Again, I mentioned we have a Discord server. Yeah.
I wanted to back up a little bit on the general purpose of what we're trying to accomplish here.
Yep.
Not having been a teacher, I've worked in industry my whole career, so I never had to teach either at any level. But let's say I were to be a brand new professor stepping into a college and I said, I'm going to teach inorganic chemistry. Someone reviewed my credentials to say I was qualified to do that, and then does someone say, well, does the chairman and the department say, show us your syllabus, we're going to approve it, or is it a free-for-all? I mean, how does anything, is there any kind of standardization that says it? You don't understand the sense of my question, if not.
Yeah, I've got what you're saying here. So, one of the reasons that I think there are so many different inorganic courses is because it's not a prerequisite for anything. It's not like students are taking it for a pre-med or anything like that, right? You don't have to worry about, you have to get to Organic 2. Hi, Benny.
Hi, everyone.
Okay. Or to biochem or anything like that. So on some levels, yeah, it is a free-for-all. Basically, we can teach what we want, presumably with the appropriate rigor. That's a tough thing to figure out your first time through. But it really can go wherever you want. Now, I think those papers give you some rough guidelines of, if you were going to spend your entire course, talking about, acid-base leveling effect kind of things, you're probably doing a little disservice to your students. They're kind of sort of these overarching topics. You'd want to spend some time on molecular orbitals, most likely. You'd probably want to talk a little bit about d orbitals and transition metal chemistry a little bit but how much and exactly what, it is a pretty free-for-all. I might turn to some of my colleagues at other institutions. I'm at a private institution, so, academic freedom, woohoo. The department head would not be reviewing my syllabus the first time through, other than, they do come in and observe your courses, and presumably tenure is something you'd like to get. So you do want to keep them happy for those purposes. But again, if you're in an institution where you're the only inorganic chemist, what's a biochemist going to tell me about what's in my syllabus? Not much.
So I teach here actually at college in Curricula college institution. There's a lot of levels for course development on this campus. However, once the course number is assigned to the class, there's less restrictions on what can actually happen. So we actually review it through a departmental curriculum committee first, and then it gets approved by a school-wide curriculum committee. And if it's going to be a new program or something, then it has to go through a college-wide curriculum committee. And so there's a lot of oversight. I assume you're thinking, like, if you're going to step into a position and serve as an adjunct role, or like a visiting professor might be a little bit different. There might be more like oversight in what's normally taught in that course, but you would have freedom to teach what you want in the course itself. So there may be a list of topics that you want to teach, and you would kind of fill in with a curriculum that you would be given to teach. At least that's how it is here. And I think it's a powerful tool because it actually gives us the ability to see what's being taught across campus. And also to make sure that we're using more like inclusive pedagogies and active learning or whatever it is that we want to do in our classes, because people are actually observing what is going into the syllabus and the activities. I also serve on the Liberal Learning Council on this campus. And people are pretty like actually reviewing the topics and the types of readings and activities that are being done. And we do provide feedback to the groups that give us these syllabi and say, these are great things. These are things that could be worked upon. We approve the course, but think about incorporating these types of things so that people are constantly growing as academics. So, but I think every school is a little bit different. I think for a public institution, we have a lot more layers because we are a public institution versus a private institution that may have a little bit more freedom.
Just, that's good.
Well, just to kind of follow up on that idea, there's stuff that is stored, right? So maybe more oversight, also needs more support versus we freedom to use have at it. Good luck. So there's pros and cons. I'm sure there's great things about both of that, but do you find that some of that oversight is constructive and helpful as people are getting going, or what's that experience?
I would say for the most part, I mean, I think there's a lot of support, at least on this campus, to like be innovative in the classroom, but I know that's not the case everywhere, and there's no support. I think for our department in particular, we share everything. I mean, and we are very much all about being on the same page with all of our curricula. And I'm lucky because I have 3 people that teach in organic chemistry. Levi is one of them. And so, yeah, we can do a lot. We have a lot that we can explore, but we all, at the end of the day, we have the same syllabus. It's just our framing is a little bit different. But yeah, if you don't have support, then it becomes very challenging. And so we wrote a book chapter about this, and I think that the best thing that you can do is start grassroots and build your way up. And so we, found this core group, and we're just like, all right, we got to make a change. And then it turned into, oh, the school has to make a change, and our dean recognized that. And then it's now now our dean is the provost of the college, and he recognizes that the college needs to make a change. And so if you have other faculty in your department that really want to make change in your curriculum, start small and then expand using your school if you have a school level platform with which to work. And yeah, we can certainly talk to you offline about it, because I think since I've been here, there's been significant change. Like I taught my inorganic course, very traditional, but now it's like super non-traditional. And I've made a lot of changes, and that's because I have support from other people, like helping out with different ideas and saying, oh, this could be innovative. I could bring this into the classroom and try these types of activities. So.
Full transparency, I would say that, my first time or two going through my inorganic courses were the inorganic chemists at my institution before me gave me their notes, and that with my undergraduate institution notes, I made a course. Someone in this room may have survived that course.
I still have the notes.
But those notes were not laminated, and that course has changed tremendously since Abby was in it. A lot of it through support from my Viper folks, because again, I'd be alone, but I've always felt kind of driven, like what can I do better in the course? So a lot of those ideas have come into my course, and we do a lot of literature discussions, less lecturing, that kind of thing.
So to follow up, my original question was just for the undergraduate level, and that's where we want to focus. But in my memory, this is many years ago when I was an undergraduate and undergraduate, there's a dramatic difference on how courses were taught. Justifiably so. When you're a graduate student, you should know something. Here's the book, go at it. We can teach you. You can go to a professor, you come see if you want. As an undergraduate, of course, you're really learning this stuff for the first time. And you get, not that the professors weren't willing to talk to you and help you. Most of the time you're talking to the TA. And I know this is different, but when I was an undergraduate, when I became a graduate, of course, I was the TA that, talking to these undergraduates, they were more comfortable maybe coming to me than to the professor for whatever reason, even though they were open to it. Is it, how does the interaction with your TA must have some, especially if you're the only inorganic chemist, then you probably don't have a lot of TAs in inorganic chemistry. You're right, that's what I thought.
Right. So, again, that's an institutional size kind of thing, but I can relate to that with the reason I'm in the position I'm in now is because I was that first year TA at one point, and I'm like, these poor students that are coming to me, I'm just some dumb schmuck. What do I know? I didn't have to do that as an undergrad. I went to the professor. That was really nice. So that's kind of where I've gone to. So I don't know if anyone in this room has any experience with courses big enough. I know we have some folks in Viper that do. Megan Porter at Indiana, for example, teaches a really big inorganic class, and she works a lot with TAs, and she's done some really amazing things. That I can only say she's done some really amazing things, but I haven't seen it firsthand. So it's done. I just have no experience with it.
It's a good question to ask because one of the conversations we're having, and I'm sure other institutions in this room are probably having, is like, how do we support college? And so a lot of places are looking at master's programs and small grad school programs, and that scares me. It's a conversation we're having here at TCNJ. Because I wanted to teach undergraduate. That's what I wanted to do. And so thinking about how I would go about doing that is kind of concerning to me. But yeah, we don't have TAs here. We have actually what's known as learning assistants. And I know that Lafayette has this type of model too, where we have the students that previously have taken the class come in and help out with the class in some way. So they come into the lecture, help with problem solving, or into the lab. And also teach. Like I teach my inorganic lab. I have 20 students in 2 labs. It's a lot of students. And so that's big for its undergraduate institution. So if you come into my lab, I'm constantly running around because everyone has questions. And having the learning assistant or the undergrad student that's been in there can help you. Like, oh, you need to set this up this way, or they can answer questions that I simply can't ask or answer the way that they might want to address that. So that's one way that we started kind of using undergrads as a way to build connections with the students in the classroom and think about how they might answer questions differently than how we would as faculty. They're often thinking about answers like you're saying, this is how I was taught, this is how I would approach the problem, but students come up with all these crazy ways to answer questions that are not incorrect. It's just a different way of thinking. And so sometimes having the students in the class helps out with that. But to get back to your other point about teaching graduate students, I think like from talking to my colleagues that are at R1 institutions, they are changing the way that they teach as well. And I think, I don't know if you're going to get into this, but when they do these workshops, Viper does these workshops, they're bringing in faculty from R1 institutions, and a lot of their goals are to, incorporate their literature into the classroom at both the graduate and at the undergraduate level. And so they're recognizing that students are learning differently in this new environment. And, I think everyone's kind of going away from the traditional lecturing 100% of the time to some kind of combination of different activities and classes.
Other questions? Anything else? I was going to transition a tiny little bit at this point, but I'm certainly happy to stay in this space. It's not going to be much of a transition, but we'll hop into the lab part. So, what's taught in inorganic chemistry labs? A little bit more recent on this one. Just came out, I think, about a month ago, maybe a little less. But we did a survey on what's taught in inorganic labs. And this is out in JChemEd. And again, most but not all of the authors are members of the Leadership Council of Viper. Well, first of all, is there even an inorganic lab at an institution? And when is it? That's incredibly variable. Some institutions reported no inorganic lab. independent labs tied to the sophomore level course, tied to the senior level course, incorporated in some bigger super lab kind of component. Incredibly variable.
I just want to get the citation.
Absolutely no problem.
Thank you.
You bet. There's also a bit of variability in what the prerequisite is for the inorganic lab course. Again, kind of all over the place. Generally, general chemistry is sort of a requirement, but not exclusively. There's some that have a pretty heavy orgo prerequisite or co-requisite. A few that have PChem and analytical. Not too many have biochem as a prerequisite, surprisingly enough. But so yeah, just like we saw with the lecture courses, the lab courses are very, very variable across the curriculum. In terms of topics of emphasis, where am I coming up with that word from? Emphasis, synthetic methods. Yeah, it's a big thing, big part of most of these, and characterization, purification to some extent, professional skills, not so much. A few have a very heavy incorporation, and that could be things like writing, presenting, those sorts of different topics. As far as synthetic methods go, again, there's a lot of variability in atmosphere techniques, catalysis, working with vac lines or dry box kind of things. Again, probably showing faculty bias there. Organometallic chemist is probably not going to go out of their way to use a high temperature furnace kind of reaction. A solid state chemist is probably going to go out of their way to do so. And that's all okay. Students are getting a great experience no matter what it is they're doing. And if you can transfer excitement about what's going on in the lab, whatever you're doing, I think that's doing the job. Yep.
Are these standalone labs of classes? Are they class and lab combo type things, or it depends?
It depends.
Okay.
Yeah. So the numbers are coming from anyone who's responded.
Okay.
Yeah. I don't think we went as far to break down by the individuals just because the end values were a little bit small. Purification techniques, so recrystallization, not too surprisingly. We can argue about whether rotary evaporation should count here or not. I may have lost that battle. Some different types of chromatography and sublimation and other sorts of things are used, but it would certainly seem, if you were building an inorganic lab, you'd want to do a recrystallization at least once. Characterization methods, not too surprisingly, IR, UV vis towards the top. Inorganic chemists tend to make things with colors, so it's not too surprising we do UV visible spectroscopy on it. NMR actually came out a little higher than I thought it might. I was kind of happy to see that. 81% report using NMR, at least of some kind of single nucleus. Magnetic susceptibility, melting point. I was a little surprised that one was as high as it was. And then a couple of other different things, including X-ray diffraction studies working their way.
I'm a little surprised that aspect's very low on the scale. I imagine that organic chemistry is more there than inorganic. Is that
Yeah,
nature of the beast?
probably a little nature of the beast. I do a GC mass lab where we, kind of look at ferrocene, athenosine, and osmosine because they'll fly through our GC mass. But I don't know that, again, small college kind of bias that I'm coming from. I don't know how many folks are going to have access to a mass
spec. It's expensive to have one.
Yeah.
If it's a small school, you might not.
Yeah, and if you've got a GC mass, you're not flying solids through it. So
add on to that. You're not really doing mass spec. You know, most of the stuff is ligand characterization at that point, right? So if you can do it in MARM, you can do a melting point. Why would you bother doing a mass spec at that point? If you can already tell what
It's you know.
I get, you know, that's a good technique to have.
Yeah.
Right? But looking at this, you know, just from a wide view, I'm looking at, okay, in a MARM melting point, they're really just synthesizing ligands and trying to figure out the ligands. So that's
The one I do, basically my class traditionally runs Monday, Wednesday, Friday, and the first lab is the first Tuesday. So we've met, you know, we talked a little bit about the structure of an atom because, you know, they've had like a whole couple weeks off, so everything's gone. So we kind of do it, you know, we look at the isotopes of iron and ferrous. You know, not that our instrument is really great at doing that. If they go through and do the calculations, our atomic mass of iron does not match what the periodic table says very well from a mass spec, but it fits. So that's kind of why
I remember, I don't know if I was a senior at the time, but we had a course which was called instrumental analysis at the time. And toward the end of the course, they gave you this unknown, and they said, have at it, no instructions, okay? I mean, you can ask all the questions you want. Can I do this? Can I use the mass spec? Yeah, go to Joe Blow, he'll do a mass spec for you, or do IR. We did all that, it's unknown, and it turned out a sample that I guess we did in groups. My group got the right answer per se, and we turned out it was one of the graduate students' experimental compounds, and they wanted to see how these goofy undergraduates could handle it. And you know, good for us. We got an A for it, but it was fun. I mean, we didn't know up from down what this compound was. It was a certain color and have at it. I mean, that was probably the most thing I can remember best.
Yeah.
How many years ago that was?
Yeah, I just finished teaching a course for the first time on like structure determination methods, and ideally they were going to do GC mass, and our old one died, and our new one got installed at the end of the semester. So they learned a lot about 2D NMR and figuring out structures. It was kind of fun. So, did you have a hand up, Abby?
Yeah, I was just gonna say that I use mass spec, or GC mass spec too, but in a catalysis lab. So they make the catalyst, they characterize it, and then they do a cross coupling with it. And so that's a great way to show them like what you would do in an industrial process if you were going to go ahead and go into industry and actually work on these small molecules and how you might optimize a catalytic experiment. So that's how I utilize mass spec. But yes, not everyone has one, so it's kind of a small. If you have one, I try to use as many different instruments as I can, but it's not for everyone.
Now, even though it wasn't rated very highly as covered in lab, it sure seems like a lot of people reported that, all right, writing is an important part of the inorganic lab component. Lab safety, would have liked that to have been 100%, but it's what was reported. Working in teams, literature searching, keeping records, would have liked that one to be a little higher too, but that's what was reported. And then a few other things, working our way down. Would have liked to see ethical conduct a little higher too, but various themes. Well, it looks like you should do some coordination chemistry in your inorganic lab based on our report. From there, organometallic compound seems to be pretty high, and it's kind of a crapshoot from there. What sneaks in. And again, that's probably coming from instructor bias of where they live and what they do, what they're bringing into the lab. So some examples. All right, back to the website. So again, if you go under content and you search syllabi, I mentioned there are a lot of them. There are some inorganic lab ones here. This is actually a great example of someone suggesting something and it resulting in a change to the website. Because I went through here and was looking at all the syllabi and I was like, there's nothing that pops out as syllabi that have some lab sort of component with them. So I added a searchable feature and then went through and tagged all the different syllabi of do they have a lab component with them. And by lab component, I don't mean, this course has a lab and super general stuff. At least some kind of layout of what labs were done with that particular course. Okay, so it went from 4 pages down to 1. So you can go through and look at those syllabi and see what people have been doing in their different labs. Some of those labs are, on Viper. Some of them are in pretty much any inorganic laboratory book. The name is listed, and if you just do an internet search of that name, you'll find it or where it came from. Some of them come from JChemEd, so there's a lot of different potential options there. All right. Back in syllabi, that's right, it visualizes it if I do it that way. So again, our Discord server is a great source of talking to people about what they're doing, good ideas that you can get into from there. All right, so we've got a little time left. I am happy to pause here. If we can talk anything else Viperish, or any questions that might have generated at this point, I'll gladly do it. I was prepared to talk about SD hybrids for a little bit. I'll do that too if people want. So drive the bus. Where do we want to go?
As you're working with your R1 colleagues that are maybe connecting into this, are they offering feedback? Like, because they have received these grad students that they've got to deal with, but supposedly this really diverse inorganic chemistry background. I'm assuming if by this point they've kind of just made it, they're going to teach it to whatever they want, just kind of reset the stage. But are they giving any feedback on like what things they want to see or what would help if their students going, or is that also so independent and random depending on their specialties? But...
I think it's a little dependent on specialties, but I think the biggest thing they want to see is students with research experience. I think that will remain unchanged. I generally have gotten feedback that, our students are well prepared for going into what they're going into. And I feel like my Viper colleagues, friends, and cohorts get the same sort of feedback that there aren't any issues where there are major gaps in education. You want to weigh in on that, Abby? Sounds right.
Yeah, I would say so. I mean, I think the biggest challenge now is that everyone's kind of adjusting to what's happening in the academic landscape. And I would say for the most part, my students always come back and say that they feel very well prepared. I don't necessarily know how much content plays a role in developing good chemists anymore. I think developing lifelong learners and the ability to learn the material and to actually apply it and do something with it is much more important. And so I think, if you slow down and cover 4 topics versus 20, but you do it really well, they're going to have the same experience. They may not have seen all the material, but they'll be able to pick it up in graduate school. So that's kind of the approach that I've taken. Because I, like Chip said, you start with like everything, throw it at the table, and then see how much you can get through. But now I've kind of like said, all right, these are the 5 things I want to have covered. And I want to do a really good job at that so that the students at least have seen something with symmetry, have seen something with orbital theories, have seen something with organometallics and solids so that they can do something with it down the line.
I had a question. Back in the dark ages when I was an undergraduate, we used, I think it was cotton Wilkinson as inorganic. Is that even around anymore? Is there something brand new, different that people use?
There is, to my knowledge, not a replacement for what Cotton and Wilkinson was. Greenwood and Earnshaw was close to a competitor for a while, but I just don't see any long-term need for the compendium of everything that Cotton and Wilkinson was. The internet has essentially replaced it. I still have my copy of Cotton and Wilkinson sitting up on my shelf. It's there. I dust it off every once in a while. But no, probably the closest thing now that seems to still be published would be Housecroft Sharp, which started out as a small, usable undergraduate textbook and has grown into, yeah.
So what are you used nowadays? I mean, is there a lot of variety with the first year inorganic?
So I mostly for my time used, let's give Paul some love, Niesler, Fisher, and Tar. Because I really like the way it did group theory. I have a bias. I did not see group theory as an undergraduate. And it was my first course in graduate school. And to say it smacked me around is an understatement. So when I got into teaching, that was one of my vows. Students are going to see group theory as undergrads, and they have. I switched a couple of years ago, 2 years ago, to a LibreText, which is an open source book, because book prices are insane. And if I didn't like the book, why was I using it anyway? LibreText, open access, and you can edit it. So I have my own book that is mostly taken from what's available in LibreText, but I've added my own components that other people can adopt, use. I love the model. I think it's great because now when my course changes, my book changes. I don't have to change my course because a new edition of the books come out and they've gotten rid of something or added something new. I make a new edition of the book when I change my course. So I am a huge proponent of that project, for sure.
Yeah, and I think a lot of other people just use sections from all different books. Like, everyone is using the group theory from Niesler and Tar because it's so good in comparison to every other book. And then there's stuff that's in Housecroft. That's great. So I always just pull sections from all these different books and probably do things illegally, like post PDFs of the chapters online. But I also
behind your educational whatever thing, so only students can access it.
Yeah, that's right. Exactly.
You're off the hook.
That's right. Not that it's recorded in space.
So yeah, good. Other questions?
How do your students like the LibreText? I feel like our students always want more practice problems, and so this is a constant battle where, like, I'm giving them problems in class that I've written, but then they want even more, and so
yeah,
that's my challenge with like moving to the LibreText, because at least in Shriver and Atkins, which is what we use, they have problems.
Right. That's that's where you could possibly think of posting questions from some other source on your course management system. LibreText is not chock full of example problems or anything along those lines. I generally post the previous year's exams for them to practice and have them do problem sets. I haven't had too many complaints of, I wish I had more practice on something. Were I doing it in a first year course, I'd worry about that a lot more. But I think generally I don't have to pay $200 for this class. Somehow outweighs I don't have enough example problems. And I have tried to, in my chapters, give some worked out examples, at least for them to see.
So a bit of a diversion. You talked about the cost of textbooks. Just to tell you how long ago this was, so my chemistry textbook, I don't know if it was $6 or $7, which then was an outrageous amount of money. But when you bought all your books for the semester, it was $100 or $50, of course, a bunch of money back then. Of course, nowadays that wouldn't buy one book probably, but to let you know, we were using slide rules back then. We didn't have hand calculators. The slide rule might have cost $30, which was a bunch of money, but you really needed it, but a good slide rule. And hand calculators just started to come out, and they were like $300, which was just out of sight for anybody. Once again, compared to a slide rule of $30, 10 times the amount for calculator. And of course, the school emphasized that you didn't need a calculator as long as you got 2 digits accuracy off the slide rule. That was good for an answer. But nowadays, I guess the sky's the limit, right?
To some extent, it's.
You got a laptop, right? You're gonna have a laptop.
I've battled with calculators over time. You know, the graphic calculators, they can put information in it, which I don't like, but they like seeing the multiple line displays, which I understand and get. The TI graphic calculators are one of the things that's somehow amazingly remained very constant in price over the past.
$30 nowadays will buy you a nice.
It'll get you a
calculator.
scientific, yeah. The TIs have held around $90 for 25, 30 years, which is amazing. But they're going to be replaced by Desmos probably in the near future or something similar to that. It's technology. It's limited lifespan before something better comes along. All right. Other questions or anything we can talk about? I've been a little all over the place, maybe not as specific as you would have liked, but hopefully we get some interesting kind of things. Yeah.
So this is about the Viper learning objects.
Yes.
So I've been thinking about posting some. I know that. Yeah, I want to, but I didn't know if it was frowned upon to post them without. I think there's like an assessment part where you can talk about what was the outcome of this, and not all of my potential learning objects would have that component. I don't know if it's frowned upon to post without that or.
Nope. We certainly welcome you putting it up later. If you've got it, great, but it's not required.
Okay.
Yeah. So feel free to distribute and share. Maybe someone will give you some feedback on how their students did. That's the ultimate sort of thing. That is, weakness might be too strong a word, but that's something I wish we did better. And I'm perfectly guilty of it. I've used plenty of things and not given any feedback on how outcomes have gone. But it's better to share it than to keep it to yourself. So please post away. Anything else we'd like to chat about? I'm not going to try and rush through SD hybrids. I'll get Adam to do a SLiTHEr with me in the future to share that with. It's fun, I promise. But I'll just kind of sit through it to get to the end because I did promise people this was going to happen. There's a lot to get to there. There's our sneak peek. So it's about time for the next Viper t-shirt to come out. Based on some discussion on the Discord, we like this Inorganic Chemistry's Advanced Kindergarten. We care about shapes, colors, and counting kind of tagline. I think it's very fitting. So we will be kind of announcing that, looking to take orders in the near future. So you've been warned. That's what it's going to look like. Somehow I got the aqua passed. I don't know why, but that's where we're going there. And we'll just finish off with thanks for having me here at MARM, giving me a chance. Thanks for showing up and talking. I'm so glad I wasn't just talking to no one, and for all you contributed and all the great questions and all that kind of thing. We currently have NSF IU's funding doing all this. We are working on the next generation grants, which will be submitted in the next month-ish. So hopefully lots more to come from us. We've got some great ideas coming forward. And with that, I will officially thank those of you that came online and were here. Thanks, Carmen. Appreciate the comment. I'm going to end the recording.